All right, this is a continuation from for the Chapter 4 Test Review Worksheet 3. This is number 2. Now, this problem here is going to be very much similar to number 1. Same type of questions, just a different graph. So let h of x equal to the definite integral of f of t dt from 6 to x. So think of f of t as the derivative graph of h of x. So just like before, we are looking at our derivative graph here. So if we want to find h prime of x, well, we're going to go ahead and just find the relevant information that we're going to need later. So we're going to need h prime of x, we're going to need h double prime of x. So to find h prime, we can find it's essentially a derivative of a definite integral. Use second theorem of calculus to evaluate, where we just have to take care of the upper bound. So plug x in for t, so f of x, times the upper bound's derivative. So the derivative of x is 1. So f of x times 1 simply leaves us with f of x. So h prime is equal to f of x. And we're going to need h double prime as well. So if I find the derivative of h prime, I get h double prime. And likewise, f of x turns into f prime of x. Okay, these are all line segments, so we can just find the areas of all these regions made up of triangles and squares. 1/2 base times height below the x-axis, so that's negative 1/2. 1/2 base times height, so 2 times 2 divided by times 1/2 is 2. This is a rectangle, sorry, so 1 times 2 base times height gives us 2. Triangle, 1/2 base times height, 2. Area of 2. 1/2 base times height here, we get negative 2 below the x-axis, and again negative 2. And then finally, positive 1/2. Okay, so part A, find h of 0. So h of 0, we go back to our definition of h of x. So the definite integral from 6 to replace x with 0 of f of t dt. And we want the lower bound to be the smaller values. So I'm going to flip the upper and lower bound, pull the negative outside. So the definite integral from 0 to 6, we can just simply combine these values that we see here. So we have 2, 4, 6 minus 1/2. So that'll give us 5.5. Okay. But we have to include the negative in front, so negative 5.5 or negative 11 over 2. Okay. Part B, find h of 6. So to find h of 6, we're going to plug 6 into the upper bound. Now here the upper and lower bound are going to be the same value. This will not provide us with any area for us to find, so definite integral simply 0. Okay, h of 10. To find h of 10, plug 10 in for x, so the definite integral from 6 to 10. So from 6 to 10, we can just add up these areas here. So negative 4 plus 1/2. I'm sorry, from 6 to 10, so just negative 2 and negative 2 gives us negative 4. Okay, part D, find h of 11. So this is where replace x with 11. So similar to part C, it's just that this is where we do tack on the 1/2. So negative 2 minus 2 plus 1/2 gives us negative 3.5. To find h prime of 3, we look at the definition for h prime of x. H prime of x is f of x. So we simply replace x in for replace 3 in for the x's. So f of 3, we simply look at the ordered pair. F of 3 will be y value of 2. Part F, find h double prime of 9.5. So 9.5, well, h double prime of x is equal to f prime of x. So we're just essentially trying to find f prime of 9.5. So the slope at 9.5 for the graph. So if we look at this graph here, this is the f of x graph. 9.5 would be somewhere on this line. So if I can find the slope of this line, then any point on that line will share that same slope. So the order pairs at the end of those line segments are 8, -2 and 11, 1. So if I find the slope between these two ordered pairs, so -2 minus 1 over 8 minus 11, -3 over -3 equals +1. So f prime of 9.5 must be equal to +1. Part G, for what value of x is h increasing? So we're looking at the h prime graph, essentially. The f of x graph is the h prime graph. So anything above the x-axis represents positive slope. Anything below represents negative slope. Critical points are the x-intercepts. So 1, 6, and 10. And we just create a sign line. Below the x-axis, negative slope. Above the x-axis, positive slope. Below the x-axis, negative slope. Above, positive slope. So h of x is increasing at the intervals from 1 to 6 and also from 10 to 11 because h prime is positive, greater than 0. For what value of x is h prime decreasing? So h prime is decreasing. H prime decreasing would be asking us to find where is h double prime negative. Okay, so this should say h prime is decreasing. Okay, h prime is decreasing from 4 to 8 because h double prime is less than 0. So this is asking for us to evaluate the slope of h prime. When is h prime decreasing? So negative slope would occur in this interval from 4 to 8. Okay, so h prime, so that's a typo there, should say h prime of x, not h double prime. H prime is decreasing from 4 to 8 because h double prime is less than 0. Part I, find the absolute extrema of g on the interval from 0 to 11. So we are trying to find the absolute max and absolute min on a function on a closed interval between the function. So we test endpoints and critical points just like before. Extreme value theorem. We're putting using extreme value theorem to find these to help us find these order pairs. So we're going to be testing the endpoints as well as the critical points. So h of 0 we found from before is -5.5. H of 1, okay, so plug 1 in for x, definite integral from 6 to 1, but I'm going to flip this so that we can evaluate it using with the lower bound being the smaller value. Pull a negative out. So from 1 to 6, we see that from the graph, we see that the regions there will add up to be a +6, but we pull a negative in front, so therefore -6. H of 6 we found from part B, that's 0. H of 10 we found from part C, that's -4. H of 11 we found from part D, -3.5. So we compare all these y values, -5.5, -6, 0, -4, -3.5. So the smallest value that we see is -6, so that will be the absolute minimum is -6 at x equals 1. And the absolute max will have to be 0. Okay, so absolute maximum is 0 at x equals 6.